All right, Charlie, let's go ahead and get started.
Cool.
And if people are late joining, they can jump in. So welcome to the Jupiter and Megapixel presentation of exploring next-gen large display technology. We're specifically today going to be talking about the Jupiter Zavus Extreme Pixel Micro LED video wall and Megapixel VR processor that is embedded into our panels. So go ahead and get the next slide. So our presenters today, we unfortunately don't have George with us today, but we have Charlie Montoya, who's our Senior Director here, Senior Director of Enterprise Sales at Jupiter, and Andy Beaudet, who's the Key Account Manager for Megapixel. So today what we're going to do is we're going to kick it off, and then Charlie will speak first about the Zavus XP, and then we'll turn it over to Andrew for a product overview on the Megapixel product, and then we'll take some Q&A. But again, like I said before, if you have questions, go ahead and type those into the Q&A, and we'll try to answer those as we go along, and then have some questions at the end. So with that, I'm going to, oh, go ahead.
No, I was gonna say, hey, actually, I have some of our team members from Jupiter on the call as well. So if there's any points that I missed, please throw it out in chat so I make sure that I touch on it. I want to make sure I get all the information out there. So I want to make sure my team's checking up on me. I want to make sure we're doing good.
There you go. So. Exactly. All right. Well, let's go ahead and turn it over to.
Right. So hey, everybody. So to get started, right? One is the question we get most often is, who's Jupiter? What are you doing? Why are you getting into 21x9? Why are you going even bigger than that? And really, Jupiter's been one of the world leaders in video wall processors for well over 40 years now, right? That's where our DNA started at. And about 4 years ago, we got into 21x9 because we knew that was the next generation of technology that was going to be driving the displays. So we wanted to be a big part of that. When we started to get in that, we noticed that while customers love the 81-inch experience, the 105-inch experience, there's definitely a need for bigger, right? And once again, we live in a world where bigger is better. We can see it because, you know, we were reminiscing before this call about how long we've been in the industry. I remember when a 27-inch monitor was considered big for your house. I got an 85 at my home now. So bigger is better. It's continuing to grow. So we wanted to make sure that we had displays that not only took care of the conference rooms, but could also go into the boardrooms, the auditoriums, the hallways, the museums, the convention centers, and still be able to get the best quality possible. So with that, we wanted to continue to drive the business. So what we did is we started to focus on what we call chip on board, or what the industry calls chip on board. Now, what's interesting about direct view LED or large format displays, if the overwhelming majority of them today sit in the 720p market, sit in the 1080p market, they really haven't jumped into that 4K or 5K. So we said, hey, look, this is an industry that's not being touched by anybody. We know we make great quality. We know we produce great image quality. We need to continue to drive that. We need to continue to build on that because 21x9 is the future. And we want to make sure that we're leading the way and being able to drive the technology for customers. So, you know, once again, you can take a look at the slide, just if you're wondering a little bit more about who Jupiter is, right? Tons of command and control centers, over 90 different locations, 40 plus years in the industry. But this is a big thing for me. This is what we really wanted to start when we wanted to get in the 21x9 area. We didn't want to just be that one-trick pony. We didn't just want to build LCD for the conference room. We wanted to make sure that we could build it for the desktop with our PANA 34-inch 21x9. We wanted to make sure that we could build it for the conference room, which is our PANA 81 and 105, soon to be coming out 94s. And then we wanted to make sure we can continue to grow it from there. 165, 205-inch, 281s. We do custom sizes as well. But we wanted to make sure that we could keep the same quality across the board. So what's made us known in 21x9 on the LCDs? It's been the high contrast ratio, the high brightness, the simplicity, the ease of use, right? You can take any of our LCDs in the market today and put it up against the competition, and you're going to be blown away by our quality, our simplicity, our design. We wanted to make sure we could do that in the large view displays as well. So for us, it was also all about building the right hardware. And really today, there's a couple ways of doing this, right? If you take a look at most companies out there today are doing what's called SMD, right? Which is just simply, hey, I have a panel and it has a bunch of LCDs on it, or it has a bunch of LEDs on it, and you put it up on the wall and it's very fragile, right? You really can't get close to it because the closer you get to it, the more pixelated it gets. We wanted to make sure that we had something that could really help change the market and help continue to drive the market. So we built our technology on flip chip COB. And I actually have one right here. So I'll stop the video at the end and show you what it looks like. But really, we wanted to make sure we could give you best in class, best in quality, that is really rigid. One of the things that really concerned me a lot when I first got into display technology, especially for the large displays, was that they were so fragile, right? You go watch people do an installation, and in just an installation, a lot of those DV LEDs, they're popping up LEDs. They're popping off little fragments of it. They're breaking it. Not with our chip on board, right? With our chip on board, they're extremely rugged. I can touch them. I can run my hand across it. I don't have to worry about people scratching it, right? So we really wanted to make sure that it was extremely rugged, as well as extremely durable, but also give you the best quality possible. So in saying that, you can see we are one of the only companies out there today that are doing true 5K quality on large displays. Most companies out there today are still doing 720p, still doing 1080p, still really kind of going with that old quality technology because it's extremely inexpensive. And I'm going to actually use the word cheap. I hate using the word cheap, but I'm going to use the word cheap for a minute. It's very cheap, but you get what you pay for. When you walk up to a chip on board wall and compare it to a traditional DV LED wall, you'll be blown away by the quality difference, right? And we build these in 0.7, 0.9, 1.2. For those that might be new to large view LED displays, what that simply means is the lower the lower the point, so 0.7 is the lowest direct view LED. At 0.7, I can be standing a foot away and it'll be crystal clear quality. At 0.9, I can be standing about 2 or 3 feet away and it'll still be crystal clear quality. We're one of the only companies that do chip on board at 1.2, right? So that means you can be about 4 feet away, 5 feet away, and it's still going to look crystal clear. The reason we do this is because we want to make sure that we can bring it to the masses. We want to make sure that we can offer great quality video at a great price point. Now, one other big portion about this is the quality. Look at the contrast ratio. I read an article from one of our competitors, and I loved it. I wanted to quote it, but I won't tell you the competitor's name. The competitor came out and said, if you want to decide what quality, what product you want to buy, the one actual stat that you want to look at is their contrast ratio. What is their contrast ratio? Our contrast ratio is 1,000,000 to 1 on our Zavus XP products. 1,000,000 to 1. I can tell you when you walk up to these, when you look up close at them, it's almost lifelike. It's almost 3D-ish, right? The way the movements, the way it flows, the quality that you get out of it, it's remarkable how good it looks. It's remarkable about how simple it is, right? So, I mean, it's just amazing to go out there and see what you're able to get with these. So once again, why? Why are we doing this? Why are we continuing to drive the technology forward? Why are we continuing to try and do better and better quality video? It's because we know at the end of the day, If you look at the way networks are going right now, if you look at the way the industry is going right now, higher quality is going to be available for more of the masses in the coming years. Higher bandwidth is going to be available for more of the people in the coming years. So your video quality is going to need to continue to grow. Your video quality is going to need to continue to get better. And the one part where you don't want to fail on video quality is what I call the last mile, and that's the display. The last thing that you want to do is have a low-end display when you're trying to show high-end content, right? So we talk about contrast ratio 1,000,000 to 1. Well, look at the stat right above that. Our actual nits, right, the brightness of this can go anywhere from 300 to 1,000 nits. I'll tell you, we actually had one of our Pana X's that can get up to 1,000 nits, and I think we had it at like 70%. I was getting a suntan in front of it, right, at Infocom. It was really bright. The whites were blinding. But that's what you're able to get. That's the quality that you're able to get. Now, for us, this is all a matter of making sure that we can continue to support the customers that are looking for that top level quality at a great price point as well, right? So it is about quality for us. It's all about quality for us when you start looking at our Zavus products. Now, I mentioned we have 3 different styles. We have our 0.7, right? So I get the questions a lot of, where would I put these different things at? Where would I put a setup like this at? 0.7, which is our lowest pixel pitch, is great for conference rooms. It's great for areas where you're going to be extremely close to the video, right? I'm going to be very close to that wall, so I need to make sure that it looks perfect. That's what 0.7 works perfect for. Our 0.9 is great for hallways, auditorium settings, areas where people are going to be walking through. I can tell you today, we get more people coming to us that are in high-end universities, that are in the healthcare industry, that are looking for high-end, high-quality displays for their entry rooms, right? When I walk into a lobby and they want to, kind of showcase all their products, their features, all about who they are, our 0.9 pixel pitch works perfect for that. 1.2, seen a lot of this go into our command and control centers, right? We've seen a lot of this come into areas where people are farther away, but they want to throw up a lot of content. Once again, all of these systems have the ability to be about customized on size. So yes, we have 165-inch, 180-inch, 240-inch, but we can also customize them to whatever size you need. Now, I'm going to stop sharing for one moment. And Andrew, I'm gonna send over host duties for you, but give me 1 second before you start presenting. What I want to do is I actually want to show you all what one of our, there we go, what one of our panels actually look like. So if you've ever seen a DV LED before, one thing that you'll notice is they're typically really bumpy because you got all the LEDs that are popping out of them. And if this was a traditional DV LED, if I rub my hand against it, all I'd be doing right now would be popping off all the little LEDs and scratching it up, and people would be screaming and yelling at me. Not with our chip on board, right? With our chip on board, it's completely flat. It's completely flush. I can rub my hands against this and I'm not scratching it or damaging it in any way. Why is that important? Because when you're looking for a product to put in high traction areas where people are going to be walking around, coming up to it, little kids might be touching. I just got back from the Aquarium of the Pacific, and then we went at the Aquarium of the Pacific. They have these huge DV LEDs, and they literally have lines in front of them. They literally have just kind of a line so you can't get more than 2 feet from it because all they are LEDs. And kids are just running their hands across those and popping them off. Not with chip on board, not with flip chip like this. I can touch this all I want. I can scratch all I want. I'm not going to do any damage to it. So when you're looking for those high quality with extremely durable that you can put in high density locations that might get touched, they might get scratched on, chip on board is perfect for you to go with. Now, in saying that, our displays are phenomenal, but they wouldn't work as good as they do without Megapixel and their Helios process. So I'm going to have Andrew talk about his part here.
Thank you, Charles. Hang on, we're gonna switch over, and I'm gonna shout out to my good buddy Sergio, who's on the call. I'm glad to see he's here, and hope you're doing well, my friend, in Vegas. Let's see if I can share now. Let's see, and when I go here, share that. Hopefully everybody's seeing the screen, seeing the Megapixel logo. Are we good? Awesome. All right. Well, thank you again, Charles, and the folks at Jupiter for inviting me to take part in this. I am Andy Beaudet from Megapixel. Today, I'm going to give a quick overview of Megapixel and our advanced pixel processing platform, Helios, and how our integration with the Jupiter Zavus LED tile makes a great display look even better. That's kind of the goal here, is to try to get us to a point where everything is really performing at the top. So very quickly, we are Megapixel. We were founded in 2017, specializing in the design and development of leading edge LED technologies. We work closely with our trusted LED tile partners to maximize LED performance to get the best visual images possible. Our team has a deep and long-standing experience in live events and spectaculars, film and video production, as well as some of the largest fine pixel pitch LED installations out there. We are innovators, and we have the awards to show for it, as well as over 200 patents and several Oscars for visual effects, many of which were the first of their kind applications that pushed the limits of technology. Megapixel worked hand in hand with the studios and creatives to develop the Helios platform into the preferred tool to drive high color accuracy and on-camera LED displays. And recently, the Eurovision 2024 Song Contest showcased Megapixel Helios in disguise with an all ST2110 signal distribution, including the use of the new Megapixel 100 gig QSFP input module, and the event went off flawlessly. We'll talk about ST2110 in a few minutes, but I bring this up because events like this are mission critical. The LED cannot fail in a multi-discipline live broadcast like this. Megapixel was a partner for a reason. The organizers know that if you want reliability, you must have Megapixel. So now let's take a look at the Megapixel Helios pixel processing platform. It's a mouthful sometimes when you got to say it fast. The two pillars of Helios are the high performance video and pixel processing, and we are the leaders in LED video performance, matched with an exceptional user interface, with tools that speed setup and troubleshooting on day one, but also offer diagnostics for the entire solution, including heat mapping the display, data errors, fiber transceiver power levels on each end, etc. We're monitoring all aspects of the system to predict and spot problems on day 2 and beyond using Helios, and we can take that monitoring even further with our Omnis on-prem monitoring and logging and alerts, and also to Megapixel Cloud for cloud-based monitoring and control. The two pillars, let me get here, sorry, there we go. Helios is an 8K native processor, which means we have a canvas of over 32 million pixels inside, but we can right-size the solution for you if your wall is smaller than that. However, having that overhead in the processor will assist you greatly if you need to add additional LED tiles later on down the road, or entire displays because of the way we can do tile grouping. Further, modularity is at the core of Helios, with input cards that can be field swapped as protocols and formats evolve. The customer who purchased Helios #1 can easily upgrade and add the latest HDMI, DisplayPort, or ST2110 inputs to their unit. As I mentioned a moment ago, we recently added that 100 gig QSFP input module that is compatible with Unreal, NVIDIA, Matrox, and others that support ST2110 with IPMX, allowing you to bring in any raster size or shape up to 32 million pixels without having to slice and dice the image into multiple HD or UHD outputs. Our latest software update includes full ST2110 and IPMX support, as well as several other enhancements and refinements, including tile grouping, which allows you to control multiple LED walls independently, but within a single Helios or Helios environment. We are TAA compliant as well, so that if you have opportunities there where you need a product that complies with TAA, we can certainly support that. However, the portion of the processing hardware you don't always see is the tile side processor, as what we call it, our PX1 card. This is factory installed by Jupiter and deeply integrated into the Zavus tile. This powerful processor embedded into each Zavus tile is part of what allows Megapixel to fit all those 8K worth of processing, that 32 million pixels worth of processing, into a processor that's only 1 RU high. So it's a very efficient process at that point. As I mentioned, we are way out in front when it comes to pixel processing. Here's an example of the same image on the same tile with the Megapixel Helios processor on the left and another very high-end processor on the right. It may be difficult to see in the slide, but the low-level detail in the Helios image is visible, while on the other processor, the blacks are crushed. You'll also know that on the left that the deep space background is actually a dark blue rather than black. So we're even able to maintain low-level color performance. If the DP or the artist wants to crush the blacks, that can be their artistic choice in the film world, but it should be a choice rather than a limitation of the processor. This ability to accurately reproduce these low black levels enhances the display's ability across the entire color spectrum as well, making a good performing LED tile even better. To give you an idea of the system layout, you have the Helios processor on the left, which usually is co-located with the video server or the video village area or whatever your video sources are. You can keep that in a nice conditioned, air-conditioned room where it's clean and safe and nobody has to physically touch it pretty much. Your content is going to be ingested into that device, into the Helios processor, in any of the standard video formats we already discussed. On the output side, you'll run standard single mode LC fiber from the Helios outputs to several Netgear switches we provide as part of the solution. And those switches are typically co-located with the LED tile, in this case, the Zavus tile. So you put the switches right behind the LED wall. This is where we right-size the system for you by providing you the proper number of switches to drive the wall. Although this is a standard Netgear switch, it is our own proprietary firmware to properly interface with Helios. Out of the switch, you'll connect to the tiles using standard Ethernet copper cabling, Cat5e or better. Our team will map out the proper number of switches and port assignments for you to get the best performance. We don't supply the fiber or the copper Ethernet cabling, as that's based on the facility layout, but all the management of the switches is handled by Helios, so you don't need to be a network engineer to set this up. Once physical installation is done, the intuitive user interface makes adjustments and configurations easy. Using the embedded web server user interface, multiple people can work on the wall at the same time from any connected device, including some operators who will use an Xbox controller to navigate on the screen quickly and easily for seam and color correction as they go along with their setup of the display. And within Helios, oh, go ahead.
Yeah, I hate to, let me ask you a question, just because I got a live question that seems like it's relevant to where you're at right now.
Sure, so, I can't see the questions as they're popping up.
No worries at all. No worries. So, do any of the new Megapixel boards support HDMI 2.1 for higher resolution outputs for applications such as esports?
Yes, so we're at, I believe, HDCP 2.2 and HDMI 2.1 on our current Megapixel HDMI input card. Excellent.
Just want to make sure I ask the question. So.
Oh, no problem at all. I always like the questions. So within Helios, we have a full suite of diagnostic and monitoring tools, including alerts, heat maps, and reports to help you manage the system from day 2 and beyond. And then we can add, when you talk about a multi-Helios facility, whether that's multiple Helioses on one very, very large wall or multiple Helioses driving multiple walls throughout the facility, we have our Omnis on-prem platform that gives you on-premise monitoring through a unified interface. However, even for a single Helios installation, the advanced monitoring and data logging, which is one of the key parts of Omnis, may still be something to consider. Of course, you can also go off-prem very easily using Megapixel's cloud solution for full monitoring and control in a secured cloud environment as well. Now we're at the point where I just open it up and I say, are there any questions? Because that's pretty much my part of it. And so Charles, I will hand control back over to you if I can figure out how quickly here. Hang on, let's
No
get
problem.
back over to this and we'll go full screen, hopefully.
Just gotta hit the stop sharing and all that kind of fun stuff. So and I've been answering, there have been some questions that I've just answered in the chat. I think there are some good questions about chip on board. What's the difference? Is there a difference between chip on board and flip chip? Honestly, at the simplistic version, they're the same term for two different things, or the same two different terms for the very similar things. Just so I can kind of cover, I want to make sure I hit on this right. So this is what's called flip chip or COB, chip on board, right? And literally what this is there's a ton of little LEDs in here that are just color coded, right? So it's very simple, very clean to get a very flat, almost like your television set. Traditional DV LED is where you walk up to, have you ever seen a large format display? You'll see there's like a ton of little LEDs in here. And if you touch them, you'll break them very quickly. So that's where chip on board / flip chip comes into play. It's much more durable. It's much more stable for people to use. I mean, this is something I would not be doing this with a normal DV LED at all, because my product management team would be coming and hitting me in the head for doing stuff like this. So just much cleaner, much simpler, much more durable for people to use. So, and Andrew, thank you for your presentation. I'm just going to pull up my presentation one more time real quick, just to kind of show everybody. Hold on. I got too much stuff going on here.
And Charles, in a moment too, I want to address the flip chip COB micro LED thing too, and just where I'm trying to go and get the industry to follow a little bit here. But go ahead, show your your slide there.
Yeah, for those people that are out there, here's all of our contact information. So if you need to contact us or reach out to us, you're more than happy to. So go ahead, Andrew.
No, I was going to say that there is a lot of confusion right now between because a lot of manufacturers are still using the term flip chip. And actually, when they're talking about COB or micro LED COB specifically, I'm actually starting to try to get the world to move away from that term flip chip altogether, because flip chip can apply to both SMD technology and if you want to think of it as COB or micro LED COB. But where there's some confusion right now in the marketplace, that some of the manufacturers are taking what they marketed 10 years ago as flip chip SMD. And at that point in time, when you do flip chip, you're taking it, or the old style flip chip, I should say, you're taking an SMD package, which is the individual LED, you're flipping it upside down so that the gold wires are actually coming down out of the bottom rather than coming over the top, blocking some of the light. But when you flip it upside down like that, you actually grind down the top, or what was the bottom, now the top, so that you can expose those phosphors. Well, a lot of those manufacturers years ago would take that, and when you have those exposed phosphors, they'd put an epoxy coating over it and make it a smooth surface, kind of like micro LED chip on board. But at the time they called it GOB, or glue on board.
Yep.
Now, the problem with glue on board SMD is that, number one, you're talking about a big pixel compared to micro LED, which is under 100 microns. The other problem is that SMD technology, as far as your heat to light to brightness ratio, is completely different than micro LED. Micro LED produces a lot of light with very little heat. SMD has always been the opposite. So with those older GOB, which they're now kind of touting as COB, it's the same. It's not micro LED COB. It's glue on board. That glue on board, those SMDs, part of the reason why glue on board didn't do very well is that heat forces the module to expand and contract a lot throughout the day. So it might look great on day one, but a week later, you're going to start seeing all these little seams around all the modules and the tiles, and you have to go and reconfigure everything and push it all back together because that heat is constantly having a problem there. So I'm trying to get the industry to move away from the term flip chip, because micro LED COB is a good enough, answer right there. It solves all the problems, and it removes the confusion about flip chip. That's just my personal
Hey, and
little thing I'm going to stand on.
No, hey, look, I'm happy you brought that up because it's true, right? And look, I'll still say this. I'm fairly new to display technology. I've only been doing it for about 2.5, 3 years now. So, it was shocking to me when I first heard of glue on board. I'm like, are you kidding me? They're really putting epoxy over? They're like, yeah, it's cheap, it's inexpensive, but we can get away with it. I'm like, yeah, okay, not as cool, right? But the one part that I would tell you about our Zavus product, talking about heat, yes, we produce 30% less heat than traditional SMD. So much so that you can actually, if you wanted to, put a touch overlay on our displays, right? On our COBs. You can put a touch overlay, and the heat's not going to affect the overlay in any way, right? You can't do that with SMB. You definitely can't do that with glue on board, right? So it definitely is a difference. And you're right. We definitely need to start educating the team. We have a lot of shows where we show flip chip. We got to get more to where we just talk about COB. I'm going to make sure I start doing that. So Andrew, I'm going to take your lead. I'm going to start just using COB. I'm not even going to use the term flip chip for it anymore. There you go.
Awesome.
There you go. So there you go.
Do we have any other questions from the audience? Sorry.
Let's take a look here. No. I don't see any other questions out there. If you do, folks, once again, feel free to reach out to us. You can email us. You can give us a call. For Jupiter, and I'm sure for Megapixel as well, please follow us on LinkedIn. Take a look on LinkedIn. You can find a lot of great information about us. This video will also be posted to YouTube later on. We have a lot of exciting events coming up. I know for both of our companies here in the next couple of months. I know I'm doing AVI Live. We got a couple other shows that are going on. So feel free to follow us on LinkedIn. You can see when we're having upcoming events where we're trying to bring a lot of this technology locally so you can see it in person. So hey, Andrew, once again, thanks again. Even though we had our Boston Red Sox argument before this call started, it was a pleasure chatting with you.
Absolutely. You too, Charles and Melissa. Thank you for the opportunity to present today with you guys. And it's a great matchup. The Megapixel processor with the Jupiter Zavus tile it's an outstanding way to go.
Perfect. Thank you, everyone. And in the post email you will get from Jupiter, you will also get a link to the presentation that was shared today, along with another more comprehensive Jupiter product presentation. Thank you.